Our planet is a blue planet. Water covers over 70% of the Earth's surface. These oceans teem with life and are constantly moving. This movement creates weather patterns and influences our climate. Changes in temperature can have a global impact. Understanding these changes is crucial for predicting our future climate. The El Niño Southern Oscillation, or ENSO, profoundly impacts our planet. Understanding ENSO is essential for comprehending our climate system. Imagine the Pacific Ocean as a giant bathtub. The water at the equator is warmer than the water at the poles. This is because the sun's rays hit the equator more directly. This temperature difference creates a natural circulation pattern in the Pacific. Warm water from the western Pacific flows eastward along the equator. This warm current is known as the Equatorial Pacific Warm Pool. This warm water brings moisture and rain to countries like Indonesia and Australia. Meanwhile, cooler water from the depths of the eastern Pacific rises to the surface. This process, known as upwelling, brings nutrients to the surface. These nutrients support a rich ecosystem of marine life. This normal circulation pattern is crucial for maintaining stable weather patterns around the Pacific. However, this delicate balance can be disrupted. Every few years, the trade winds that normally blow from east to west weaken. Sometimes they even reverse direction. This change in wind patterns disrupts the normal circulation of the Pacific Ocean. It sets the stage for the emergence of El Niño and La Niña. These events are part of the El Niño Southern Oscillation, or ENSO. ENSO is a natural climate pattern characterized by fluctuations in the temperature of the surface water in the tropical Pacific Ocean. These fluctuations are coupled with changes in the atmosphere above it. El Niño and La Niña are the warm and cool phases of ENSO respectively. These names, Spanish for the little boy and the little girl, were given by Peruvian fishermen centuries ago. They noticed the changes in ocean temperatures around Christmas time. El Niño is characterized by unusually warm surface waters in the central and eastern tropical Pacific Ocean. This warming disrupts the usual patterns of rainfall and atmospheric circulation. La Niña, on the other hand, is characterized by unusually cool surface waters in the same region. These changes in ocean temperature have far-reaching consequences, impacting weather patterns across the globe. El Niño and La Niña events typically last 9 to 12 months. However, they can sometimes persist for much longer. They tend to develop during the spring, reach peak intensity during the late fall or winter, and then decay during the following spring or early summer. The effects of these events are felt globally, bringing floods, droughts, heat waves, and other extreme weather events to different parts of the world. El Niño, the little boy in Spanish, is not so little in its impact. It is a powerful force of nature, born from subtle shifts in the Pacific Ocean and atmosphere. Imagine a seesaw, delicately balanced. That's the normal state of the Pacific Ocean and its overlying atmosphere. The Western Pacific near Indonesia and Australia is warm and wet. The Eastern Pacific along the coast of South America is cooler and drier. This balance is maintained by strong trade winds blowing from east to west. These trade winds push warm surface water towards the Western Pacific, piling it up like a giant pool of warm water. This warm pool fuels the formation of clouds and rain, making the Western Pacific a region of abundant rainfall. Meanwhile, along the coast of South America, cooler water from the depths of the ocean wells up to replace the surface water pushed westward. This upwelling brings nutrients to the surface, supporting a rich ecosystem of marine life. But every few years, this delicate balance is disrupted. The trade winds weaken, and the seesaw begins to tip. The warm water piled up in the Western Pacific starts to slosh back eastward, like water in a bathtub. This eastward movement of warm water marks the beginning of El Niño. The reasons for the weakening of the trade winds are complex and not fully understood. Scientists believe that a combination of factors, including changes in air pressure, ocean temperatures, and even underwater earthquakes, can trigger the development of El Niño. The The weakening of the trade winds is closely linked to changes in atmospheric pressure over the Pacific Ocean. Normally, there is a high-pressure system over the eastern Pacific and a low-pressure system over the western Pacific. This pressure difference helps to drive the trade winds from east to west. However, during El Niño, this pressure difference weakens. The high-pressure system in the east weakens, and the low-pressure system in the west strengthens. This shift in atmospheric pressure causes the trade winds to weaken or even reverse direction. These changes in wind patterns have a profound impact on the ocean currents. With weaker trade winds, the warm water piled up in the western Pacific is no longer held back. It starts to flow eastward along the equator, spreading out across the central and eastern Pacific. This eastward movement of warm water is further enhanced by something called Kelvin waves. Kelvin waves are large-scale waves that travel eastward along the equator. They are generated by changes in wind patterns and can transport a significant amount of heat energy across the Pacific. As the warm water spreads eastward, it has a dramatic impact on the ocean temperatures in the central and eastern Pacific. The thermocline, the boundary between the warm surface water and the colder deep water, deepens in the eastern Pacific. This deepening of the thermocline makes it harder for the nutrient-rich water from the depths to reach the surface. This disruption of the upwelling process has significant consequences for marine life. The cold, nutrient-rich water that normally wells up along the coast of South America is essential for supporting a diverse ecosystem. It provides the nutrients that phytoplankton, the base of the marine food web, need to thrive. With less upwelling, the phytoplankton population declines, leading to a cascade effect throughout the food web. Fish that feed on phytoplankton have less food available, and their populations decline as well. This can have devastating impacts on fisheries and the livelihoods of people who depend on them. The warm water that spreads across the central and eastern Pacific also has a significant impact on the atmosphere above it. Warm water evaporates more readily than cold water, adding more moisture to the air. This increased moisture fuels the formation of clouds and precipitation. As a result, regions that are normally dry, such as the west coast of South America, can experience increased rainfall and even flooding during El Niño. In contrast, regions that normally receive abundant rainfall, such as Indonesia and Australia, can experience drier conditions and even droughts. These changes in rainfall patterns can have far-reaching consequences, impacting agriculture, water resources, and human health. For example, droughts in Australia can lead to crop failures and water shortages, while floods in Peru can damage infrastructure and displace communities. The impacts of El Niño are not limited to the Pacific region. The changes in atmospheric circulation caused by El Niño can influence weather patterns across the globe. For example, El Niño events are often associated with warmer-than-average winters in North America and colder-than-average winters in Northern Europe. El Niño is a powerful reminder of the interconnectedness of the Earth's climate system. Changes in one part of the system can have ripple effects across the globe, impacting weather patterns, ocean currents, and ecosystems. El Niño, a seemingly innocuous name for a phenomenon with far-reaching consequences. The warming of the Pacific Ocean disrupts the delicate balance of the Earth's climate system. Like a stone thrown into a still pond, its ripples spread far and wide. Weather patterns that have been stable for years, even centuries, begin to shift. What was once predictable becomes erratic, and the consequences are felt across the globe. Regions accustomed to abundant rainfall find themselves parched by drought, while others, typically dry, are inundated with floods. The jet stream, that river of wind high in the atmosphere, is diverted from its usual course, bringing unusual temperatures and precipitation patterns to distant lands. El Niño is a stark reminder that our planet is a complex, interconnected system, and even seemingly small changes in one part of the system can have dramatic impacts elsewhere. The warming of the central and eastern Pacific Ocean during El Niño disrupts the normal atmospheric circulation patterns that drive global weather. The rising warm air over the central Pacific creates an area of low pressure, which alters the path of the jet stream. This, in turn, influences the track of storms, the distribution of rainfall, and the temperature patterns around the world. El Niño dramatically alters rainfall patterns. Deserts in western South America face torrential rains and floods. Arid landscapes turn into muddy torrents, destroying homes and crops. The 1997 to 1998 El Niño caused catastrophic floods in Peru and Ecuador. Meanwhile, Indonesia and Australia suffer severe droughts. Monsoon rains weaken, leaving crops withered and reservoirs empty. The 2015 to 2016 El Niño triggered severe droughts and forest fires. El Niño disrupts the delicate balance of rainfall patterns. While the most dramatic impacts of El Niño are felt in the Pacific Rim countries, its influence extends far beyond this region. The altered jet stream patterns can bring unusual weather to North America, Europe, and even Africa. In North America, El Niño winters are often characterized by warmer than average temperatures in the northern United States and Canada, and cooler than average temperatures in the southern United States. The southeastern United States tends to experience wetter than average conditions, while the southwest is often drier than normal. In Europe, El Niño can bring milder winters to northern Europe and colder, wetter winters to southern Europe. The effects of El Niño on Africa are more complex and vary depending on the region. East Africa often experiences increased rainfall during El Niño, which can lead to flooding, while southern Africa tends to be drier than normal. These shifts in weather patterns can have significant impacts on agriculture, water resources, and human health. El Niño's impact on global temperatures is also significant. During El Niño years, the average global temperature tends to be warmer than normal. This is because the warmer than average waters in the central and eastern Pacific release more heat into the atmosphere, which contributes to a slight increase in global temperatures. The 1997 to 1998. El Niño, for example, was associated with one of the warmest years on record globally. Section 4. Echoes in Time, Past El Niños and Their Impacts. Throughout history, El Niño events have left their mark on human societies. The Moche civilization in Peru was profoundly affected by El Niño's wrath. Their irrigation systems were vulnerable to floods and droughts. Strong El Niño events may have contributed to their decline. The 1982 to 1983. El Niño caused widespread damage and disruption. Severe droughts plagued Australia, Indonesia, and the Philippines. Floods and mudslides ravaged Peru and Ecuador. The event even impacted weather patterns in North America. These events remind us of El Niño's power and the need to understand and predict them. Section 1. La Niña, the cool counterpart. If El Niño is the fiery, disruptive child, La Niña, the little girl, is its cooler, more reserved counterpart. While still a powerful force of nature, La Niña's influence is often described as amplifying existing climate patterns rather than drastically overturning them. Picture a pendulum swinging back and forth. El Niño pushes the pendulum to one extreme, while La Niña pulls it back, often with even greater force, towards the other. During La Niña, the trade winds, those tireless movers of air and water, blow with even greater strength than usual. This intensified wind flow across the Pacific acts like a giant bellows, further piling up warm water in the western Pacific, near Indonesia and Australia. The sea level in this region rises, sometimes by as much as a meter, as the warm water accumulates. Meanwhile, along the coast of South America, the cooler, nutrient-rich water from the depths of the ocean is drawn up to the surface with greater intensity. This process, known as upwelling, intensifies during La Niña, leading to an abundance of nutrients that support a thriving marine ecosystem. Section 2. Trade winds strengthen their grip. As the trade winds push warm water westward, cooler water from the depths of the eastern Pacific rises to take its place. While La Niña's impacts may be less dramatic than El Niño's, they are no less significant. La Niña tends to amplify existing climate patterns, leading to wetter conditions in regions that are typically wet and drier conditions in regions that are typically dry. This intensification of existing patterns can have profound impacts on agriculture, water resources, and human societies. La Niña, though less infamous than its warmer counterpart El Niño, exerts a powerful influence on our planet's climate system. Section 2. Shifting rainfall patterns, a tale of two hemispheres. La Niña's most direct and dramatic impacts are often felt through its influence on rainfall patterns. In the western Pacific, where warm waters gather during La Niña, the atmosphere becomes supercharged with moisture. This increased moisture fuels the formation of towering thunderclouds, leading to heavier than normal monsoon rains across Southeast Asia, Indonesia, and northern Australia. Meanwhile, on the other side of the Pacific, La Niña often ushers in drier than normal conditions. Section 3. Beyond the rains, La Niña's broader influence. La Niña's influence extends far beyond its impact on rainfall patterns. It can alter the track and intensity of tropical cyclones, influence winter weather patterns in North America and Europe, and even affect the frequency of tornadoes. In the Atlantic Ocean, La Niña tends to create conditions that are more favorable for hurricane formation. With weaker upper-level winds and warmer ocean temperatures, hurricanes have a greater chance to develop and intensify. La Niña can also impact winter weather patterns in North America. Section 4. La Niña's legacy, past events, future implications. La Niña events have left their mark on human societies throughout history. Understanding these past events and their impacts is crucial for adapting to a future where climate change may amplify the frequency and intensity of La Niña events. El Niño and La Niña, though often portrayed as opposing forces, are actually two sides of the same coin, two distinct phases of a single complex climate pattern known as the El Niño Southern Oscillation, or ENSO. El Niño brings warmer than average waters to the central and eastern Pacific, suppressing the usual upwelling of cooler, nutrient-rich water. La Niña, in contrast, intensifies the trade winds, pushing warm water westward and enhancing the upwelling of cooler water in the east. While El Niño and La Niña both disrupt the normal climate patterns, their impacts on different regions of the world can be strikingly different. El Niño often brings increased rainfall and flooding to the normally arid regions of Western South America, while causing droughts and wildfires in Indonesia and Australia. La Niña, on the other hand, typically intensifies the monsoon rains in Southeast Asia and Australia, leading to widespread flooding, while exacerbating drought conditions in the southwestern United States and parts of South America. Predicting the unpredictable, the importance of understanding ENSO. El Niño and La Niña, though naturally occurring climate patterns, are not easily predicted. Their timing, intensity, and specific impacts can vary significantly from one event to the next. El Niño and La Niña, the boy and the girl. These names, evocative of childhood innocence, belie the powerful forces they represent. We are not merely passive observers of this intricate climate dance. We are active participants, our actions influencing the very forces that shape our world. The burning of fossil fuels, the clearing of forests, the relentless pursuit of economic growth at the expense of environmental sustainability. All these activities are contributing to a warming planet. A planet where the delicate balance of El Niño and La Niña is increasingly disrupted. As global temperatures rise, the impacts of El Niño and La Niña are likely to become more extreme and unpredictable. Understanding El Niño and La Niña is about recognizing our place in a complex world. Our actions have consequences, and education is key. By teaching future generations, we empower them to make informed decisions. Scientific research and international cooperation are essential. Together, we can build a sustainable future.